Let's do something slightly different over here. So let's make sure that we are in the working directory that we are supposed to be in. And then let's go ahead and issue a command which is called df, right? So this df is going to output the usage of the drives in your folder, right? So what we're interested in is looking at this line over here which says slash, right? So if you recall, everything in our hard drive is going to go under a slash, which is the root folder. So if you take a look at the line over here, you're going to see that it's telling us how many used bytes we have and how many available we have. It's a little difficult to read these, so let's go ahead and change this to df minus h. This h stands for human readable. So when we hit enter on this, we get the output over here which says that I have 14 gigabytes of used hard disk space and 39 GBs are available for me, right? So this is a command which immediately tells you how much space you have. You don't have to go to your file explorer, right click on your drive, click properties and see how much space you have. You simply hit df minus h and the information is right there for you to parse. Another thing that we can do is, and this comes in handy when you have quite a lot of files sitting in your drive and you don't know what is taking up all the space, what you can do is you can say du. So this is for usage and it's going to tell you the size of all the folders that are in your current directory, right? So all the folders along with the space that they are taking, right? So again, we want to do du minus h so that we have a human readable output over here. So as we can see, lesson 4 file is taking 336 kbs. We have 360 for the whole lesson 4 directory and everything else over here. So if you have a very large file over here, you can immediately see over here which folders are taking up all the space. This, as you can see, is not providing you the folder level output. Instead, it's going within the folder to find out everything recursively. So what we want to do is we want to instead do a summary. So that's du minus sh, right? So if you do du minus sh, it's going to tell you that the current directory takes 424 kilobytes. But now it has removed all the information. So we say du minus sh star. And what it's going to do is it's going to take a look at all the directories which are in your current folder. So this star, if you recall, is going to mean all the files in this current folder. And du minus sh is going to go ahead and take a look at all the directories, all the files which are in the current directory and summarize their disk usage for you. So lesson 01 takes 8.0k, lesson 2 takes 12k, lesson 4 is the largest one and it's taking 360k. So you don't have to go ahead and pay for a utility that finds out how much disk space is being used. You can simply hit du minus sh star and it will tell you what is taking up the space, and then you can go ahead and delete the largest files if you want. In this video, we're going to take a look at some more time-saving features. So let's first go ahead and take a look at our directory listing. So we are in our CLI working directory. Let's go ahead and enter the CLI-files-0.0. So by now you're probably sick of typing all these folder names and are looking for a shortcut. So worry not, we have a shortcut. Let's first clear this window a little bit. So there you go. What we want to do is we want to enter the lesson-04 directory. So one way to do that is to say cd and type the whole lesson 04, but we can also type just L and hit tab, and it will complete all the non-ambiguous letters for us. For instance, starting with L, we could have typed lesson 01, lesson 02, 3 or 4. So up until lesson-0, all of these were equivalent. So it has typed that, and now it's waiting for us to type the next character. So if I hit tab again twice, so that's tab, it will show me all the options that I have starting from this lesson-0. So I can say 4 and hit enter. Right, so let's do that again. Cd dot clear. So we can say cdl tab and 4 enter. Right, so that's a real time saver, and that's why we have such long folder names in Linux. And that's why I recommended that you go with a dash, because you don't really have to type it all that much, but it saves you a lot of troubles. So that's one way. Now we're going to take a look at some keyboard shortcuts that are really useful. So you've already taken a look at the Control R shortcut, which is kind of a history retriever. Here we are going to take a look at another shortcut, which is Control L. So Control L does the same thing as clear screen. So if we hit Control L, it clears the screen. So that's really useful. Instead of typing the whole clear, you can just hit Control L. And the way that people typically do this is, if you're not good at typing, you should get into the habit of doing this. You use your little finger, little left finger, to hold the control, and you use the second to little finger to hit L. So that's a real time saver. You don't have to search for the keys visually. You can simply uh, get your flash memory to do it for you. Anyway, so let's go ahead and take a look at another shortcut. So let's take a look at another command. Let's go over to cd dot dot. Let's say you were saying cp minus r lesson 05, and we wanted to copy it to lesson dash 09. Right? So we wanted to do that. But when you type that, you realize that you don't really want to issue the command right now. So what you can do is you can hold backspace and wait for 5 seconds until all of this goes away. Or what you can do is you can just hold control and hit U and it's gone. Right? So that's essentially yanking the current command or whatever is before the cursor away. Right? So you could have written anything over here and you just hit Control U and it's gone. Right? So that's very useful when you're working with some commands and you realize that you've typed the whole command. It's a really long command, but you don't really want it right now. And the good thing is that the command isn't really gone. For instance, let's go ahead and do this again. cp minus r lesson dash 04 lesson dash 09. So if I hit Control U, it's gone. I can say cd cd dash, come back over here, and I can simply go ahead and say Control Y, and the command that I yanked away can now be pasted back in. So this is copy paste at its finest. So when you hit Control U, it takes the whole command, puts it in kind of a secret clipboard, and you can use Control Y to bring it back. Similarly, what you can do is you can hit Control A, and that will take your cursor right to the beginning. So let's go ahead and clear this. Let's take a use case. So you wrote cp lesson dash 04 lesson dash 09 and you hit enter, and you realize that you've just missed the minus r. So you can hit up, and instead of holding your left cursor for 5 seconds to get to the beginning, you can simply hit Control A and then next minus r. Right? So that's a real time saver again. If you have a command that spans like 2 lines, you don't have to hold your left key for like 15 to 20 seconds to get to the beginning. You can simply do Control A and your cursor jumps to the beginning. Similarly, you can hit Control E and your cursor goes to the end. Right? So up until now, we've done Control R, which is for searching in the history. We have Control L for clearing the screen. We have Control U for cutting everything before the cursor. We have Control Y to paste stuff back in. We have Control A to go to the start of line, and we have Control E to go to the end of the line. A list of this is available in the course resources, but it's good practice to work with it in your own time so that you get in the habit of using these. If you get in the habit, these are going to save you a lot of time. These 15 to 20 seconds per command are going to save you a lot of hours down the line. Right? So those are the shortcuts that you should be aware of. There is another shortcut. I personally use it a lot, but I haven't seen many people who use it. So for instance, we have cp minus r and we say lesson 04 lesson 09, and if you want to cut it, you can say Control A and you can hit Control K. So Control U and Control K are kind of similar. Control U cuts everything before the cursor and Control K cuts everything after the cursor. So for instance, you come over here and you realize that you don't want to copy it as lesson 9. You can simply hold Control and hit K. So everything after the cursor is gone. And if you want to get rid of everything before the cursor, Control U. Right? So those are some shortcuts that are going to make your life really easy. Okay, so let's get back to some commands. So imagine that we are in this folder over here and we want to find out all the files that end with the .csv extension. So one way to do that is to go ahead and say ls lesson-01, and it doesn't have any, lesson-02, yes it has one, lesson-03, it has one as well, but that's a lot of effort. What we want to do is we want to have a single command that can find all the CSV files for us. So for that we have a command called find, surprisingly, and we say find in the current directory. So dot stands for the current directory, just as dot dot stands for the parent directory. So find in the current directory a file which has the name matching static.csv, right? So it goes ahead and recursively finds anything that matches static.csv in our current directory. So we have all of these files over here. Now find is a very powerful command. You can use it to find files matching a myriad of criteria. For instance, let's take another use case. We want to find all the files in the current directory which are of type F, which is file. You can also find directories, which would be type D, but we want to find files which have size greater than 100K, right? So if you are in the habit of downloading a lot of files into a temporary directory and you're running out of space, or you're trying to figure out what's taking up all the space, or let's say you have stuff in your Dropbox and you're trying to figure out which are the largest files, you don't need to find the utility. You can simply use find to find files which are very large. So it's this file which is greater than 100K, and everything else is either equal to or below 100K. So you can use that to, for instance, find in /home/nam. So in my home directory, all files which have size greater than 100M, right? So M would be capital, here the K was small. This is for kilobytes and this M is for megabytes. So you can find all the files in your home directory which are larger than 100 megabytes, and probably get rid of all those which are not important, right? So this is really useful. I'm not going to run that. You can go ahead and do that. If you want to figure out what other options find has, as before, you can hit man find, and it's going to give you a manual, and this is a huge manual. So if you go to the end, you can see that it has all these options. For instance, for size, we have these options over here. There you go, dash size n, and then you have the option of writing either B, C, W, K, M, or G. You can find files larger than, let's say, 2 gigabytes. It has all of these options that you can go through when you have time, and as you can see, it can find files which are newest, which are older than a particular date. All of these things are here. It also has quite a few examples, and this is like a 1200 pages long manual, so it's very useful. When you have time to go through these can save you a lot of time down the line. So one other thing that we want to do is we want to find out all the directories, all the files which are in my housing data folder, right? So I want to find out lesson 04 / housing data, right? So that's just one file which is over here. But what I'm interested in is finding a lot more information about this file. For instance, I want to verify that it is indeed greater than 100 kilobytes. So what I can say is ls-l, which is for listing, and this is lesson 04 / housing data. And now it's showing me quite a lot of information over here. So some of these are easily parsable. For instance, this nam means that this file belongs to this folder. We're going to cover this in a little more detail in a future video, but for now it suffices to say that this is nam. Forget about this for a minute, and this is the file size. This is the date of modification for this file, right? So February 24th this year and 2018. But we want to see what this is in a more human readable format. If you remember from df, we have a switch called h, so we can say ls-lh, list it in human readable format, and now this is a 332 KB file, which is indeed larger than 100K. So ls-lh is very useful when you're trying to figure out a specific folders listing and you want to find out what it has. For instance, we can say ls-lh over here, and it's going to tell us that all these directories essentially take 4.0 KB. So this is not the recursive space taken by the directory. For that, you can use du that we covered earlier, and files are going to be showing their own full size. So in the next video, we're going to do a couple of interesting things with this file over here. So stick around. So in the past few videos, we've taken a look at some commands that can really save you time in doing operations that you could have done using another method. For instance, find a utility, find a text editor that can find all the files which are larger than 100K. So we also had grep -r setosa. So you have editors which have the ability to do find in all files. For instance, they can find all the setosa occurrences in a folder. But in this video, we're going to take a look at one utility that has no alternative in the GUI world. I have never come across a better utility for carrying out this particular task. So let's start with clearing our screen, and so let's go ahead and say tail lesson-04 slash housing data AU tab. If you can notice, I'm hitting tab after writing a couple of letters, and that's allowing me to write the command really quickly. So I can say tail lesson 04 housing A, and that's it. I hit enter and it outputs some stuff over there. So the command tail is used to output the last 10 lines. How do we ensure that? We can simply pass it to WC, and WC will tell us that there are 10 lines over here. So what tail does is it outputs the last 10 lines of this file over here, just as head output the first 10 lines. So head and tail. But what's really interesting about tail is you can use it to tail a file. So essentially you can use it to follow a file around. So let's go ahead and clear this and say tail -f, and then let's go ahead and use our hello.txt file that has been sitting around for a while now. Since this is an empty file, nothing is output, but you will notice that we have not been given the prompt back. Tail -f means that we are going to keep tailing this file, we're going to follow it around, and whenever some content is put in this file, it will be output over here. So to test that, let's go ahead and open another terminal in the same folder. We can see that we are in the folder which has hello.txt, and let's go ahead and put something in the file. So if you recall, we can use echo and redirect the echo to hello.txt, and it's going to go to hello.txt. So notice this portion over here. Because this command is tailing hello.txt, when we put something in it, it's going to appear over here automatically. Right, there you go. We can say test hello.txt, and it's going to appear over here as well. Note also that when you use this redirection, the original content of hello.txt has been overwritten. That's why it's saying tail hello.txt file truncated. So in order to take care of that, we can say hello test2, and we use double brackets, and that means append to the file instead of overwriting the current contents. Right? So there you go. Test2 is available over there, and we can write anything in this, and it's going to appear over here. What's more, we can cat hello.txt, and you will notice that the file is indeed being saved. So this tail has no information about where this data is coming from. It's simply following the file, and it's outputting whatever the changes are occurring over here. So what is this useful for? This is extremely useful when you have, for instance, a server that is running and it's outputting all the information that it has onto a log file. You tail the log file, and then you go ahead and make some interaction with the server, for instance in your web browser, and whenever you get an error, you will see it over here in real time. So you don't have to go through reams and reams of a single log file to understand what the error is or when it occurred. You can simply hit tail -f, and you will be shown the last information that is available in the file at the moment. When you go to the web browser and do something that leads to an error, the web browser is essentially going to write something to the log file. So it's going to have the same effect, and the tail is going to show you at that time what the error was, and if you have proper debugging, it's going to show you all the information that you need to know. So this tail -f is like the screwdriver of system admins. They use it all the time, and it's a very useful utility, and it has no parallel in the GUI world. So again, get in the habit of using these commands. I cannot stress this enough. If you take a look at them once and then you forget about them, they're not going to be useful, of course. But if you do use them, they're going to save you hours upon hours of time. So in this video, we're going to take a look at something slightly different. On Windows, you have something called the Task Manager that shows you all the processes that are running in a Windows environment. In Linux UI, you also have a similar utility, but on the command line, it's really easy. All you do is hit the command top, and you get a real-time interface showing you what processes are running, which user they belong to, and a lot of other information about it, including CPU and memory usage. However, that's not what we're interested in at the moment. You hit Q to exit this command, and let's go ahead and clear this. What we're interested in is a non-real-time output of the same information, and we'll see in a minute why that is important. So the command for that is ps, and you pass an argument u to it. That means list the processes. This is very similar to ls, which is directory listing. This is ps, which is for process listing, and we pass it the argument u so that the current users all processes are shown. So if you hit that, you will see that I have Firefox running in my GUI. So what we want to do is we want to see the processes of all users. So we can say PSAU, and it will show us the processes belonging to not only Nam, which is my user, but also to root and to guest. Let's go ahead and clear this and take a look at another option. So this is PSAUX. So X stand for a different syntax. This is from BST, and this shows you a slightly different syntax of the same information. So you can see that it has quite a lot of processes over here, and it also has some of these processes which are in square brackets. So these are the processes which are run by the kernel. So these are kernel threads, and we don't typically want to mess with them. So let's go ahead and consider a scenario in which Firefox is stuck. So first, let's go ahead and clear this and say PSAUX, and we want to pass the output of this command to grep so that we can search for Firefox. So when we say PSAUX grep Firefox, it's only going to show me those lines in this output which have Firefox in it. So as you can see, there are quite a few over here, and it looks like kind of a mess, but the point of interest is this guy over here, which is my username. So this is my process, and this is the process's ID. So each process is identified using a unique number, and this 1342 is my Firefox's number. So what I want to do now is imagine that Firefox was stuck and it wasn't responding. On Windows, we have a thing called end process. So you go to the task manager, you right click and you say end process. And that's kind of like a suggestion to the operating system to go ahead and try to close Firefox. If you've ever been there, as everybody, you would know that end process doesn't really kill it immediately, right? It takes a little bit of time, and then you have to do a couple of end processes again, and then eventually the operating system will get rid of the stuck process. Here we have a very different idea. So once we have this 1342, which is the process ID, we can issue a command which is kill -9 and 1342, which is the process ID that we want to kill. So this kill, it looks ominous, but the command is essentially used to send a signal, and this -9 signal means terminate immediately. So that -9 is essentially the kill. The kill word itself is to send the signal. So you say kill -9 1342, and Firefox is going to go away immediately. No questions asked. So if you say PSAUX grep Firefox, not there. This one thing over here is not the actual Firefox, but the grep that is looking for Firefox, right? So this is not exactly Firefox. So as you can see, all the Firefox processes are now gone immediately, right? So let's go ahead and start Firefox again. So I'm going to do that in the background. So I've started Firefox again, and if I hit PSAUX grep Firefox again, you will see that it has now appeared again. So one way to kill it now, imagining it was stuck, would be to say kill -9 2540. So that is the new process ID for this new process Firefox. So we could have done that, or what we can do is we can say kill all and simply pass Firefox. So that is going to also PSAUX grep Firefox, and as you can see, that Firefox is gone as well because of the kill all. So kill all essentially means send the terminate signal to all the processes that are named Firefox, right? So this is by name, and the command that we passed earlier was through the process ID. Now you should be very careful about this kill all, because with great power comes great responsibility. This is not going to ask you for a confirmation. It's not going to save your work. It's just going to kill the process immediately. And this is very, very useful when you have a process that is stuck and it isn't going away. So let's go ahead and start a new terminal. And what I'm going to do in this terminal is I'm going to issue tail -f, and let's say hello.txt. So you would recall that this process tail is going to follow hello.txt because of this -f switch, and it's going to keep running, waiting until something is appended to hello.txt, and it's going to output over here. So we covered that earlier. That's not what we're interested in at the moment. What we're interested in is instead to go ahead and try and find this tail in our processes. So PSAUX grep tail, and you will see that this tail -f hello.txt is over here, right? And the process ID is 2764. What I can do is I can prove to you that it is immediately killed by saying kill -9 and 2764. Right, so there you go, killed immediately. Right, so it doesn't even wait a microsecond, it immediately kills the process. So if this was stuck, it would no longer be stuck. So in the next video, we're going to take a look at some other commands that help you work with processes. In the previous video, we took a look at how we could filter the running processes from a list. Now let's go ahead and take a look at something slightly different, which is to find out the information about our CPU. So in Windows or in another GUI, you would probably go to settings and find something like My System, and then go ahead and see what the CPU was. Here you can simply say cat/proc/CPU info, and you would get a very detailed information about your processor. So I have a Intel Core 2 Duo 300 gigahertz. Please don't judge me. This is a backup system that I'm using for the recording of these videos. It's not my main system. Don't worry about it. This /proc is a special directory which holds the information, the runtime information about processes and your system. So this isn't really a directory. It's a virtual directory that has been created in memory, and you can use it to query different types of informations. So that's all we're interested in at the moment from /proc. So we can go ahead and say /proc meminfo, and similarly it's going to show you very detailed information about your memory. So this is your total memory, your free memory, what is available, buffers, cache. It has a lot of information over here, including what virtual memory has been allocated, what has been used, number of pages. So if you're learning operating systems, or if you're taking an operating systems course and you are studying paging and segmentation, you can go ahead and look at this, and it will give you a lot of deep understanding about what's going on. Another thing that we can do is we can say cat/proc/ and before we do that, let's go ahead and say psaux grep Firefox. So this is the Firefox process that I have just started, and you can see that it has the process ID 2860. So we can say cat/proc/2860. So that is the process ID. So this process ID's information is being saved at runtime in /proc/2860, and we can say what is the status of this process, right? So status, and you can see that it will tell us a very detailed information about it. What is the name? What is the state? So it's currently sleeping. Also swap spaces, signals handled, a lot of information that if you're trying to learn operating systems, this will come in very handy. So for instance, let's take a look at this. So this is voluntary context switches. So the number of times that the process has yielded to the operating systems voluntarily. Let's imagine that we're interested in finding just this information. So again, what we can do is we can take this and we can pass it to grep, and we can say voluntary, right? And it will show us just those lines that match this. So again, it's all about composing different utilities together. So now that we have that, what we're interested in is taking a look at how the voluntary context switches are being changed, right? So as you can see, they are increasing, but it gets a little problematic to keep doing this up and waiting until it changes, right? So we have another command for that, and that is a very useful command. What we can do is we can hit up, and we have this whole command. We can enclose it in single quotes. So I hit single quote, then I hit Control A, and then I say single quote again, right? So using the shortcuts that we discussed earlier, so we can say watch and this. So what watch does is it goes ahead and executes the command that we have passed to it every 2 seconds by default. So it's going to keep executing this command, and you can see the timer over here. So every 2 seconds it's going to change, and it's going to tell us whenever the voluntary context switches are being changed. So watch does not have any understanding of the processes. It does not know how to search. All it knows is keep executing the command again and again after 2 seconds. And it's the responsibility of these two commands to come up with the information that is relevant to us. We can go ahead and change this granularity for the watch command. By the way, you hit Control C to get out, and then you say hit up, Control A, -N1, right? So N1 means execute the command that is passed to watch every second. So now this is every 1 second, and it's going to give us an updated ticker for the voluntary context switches. So this is a very useful command. For instance, when you are downloading something on the command line and you want to see how much of the file has been downloaded, you can say watch ls-l, and it's going to show you all the current directories. You can pass it through grep to focus on a specific on a specific directory, you can be waiting for some files to come down. So what you can say is ls minus l. So that shows you all the files. You can pass it to wc, and it will show you the number of lines. So that is the number of files that you currently have. You can take this and pass it to watch minus n1, and if you are downloading a large number of files, this is essentially going to keep a track of how many files have been downloaded. So this watch is a very useful command when you're working with Linux command line, when you're working on a server, when you're trying to do almost anything that requires repeated interaction.